This video is to walk you through example 1, putting it in Staplet and how to answer the questions based on that. So we've got our data right here, okay? We have age and months, and we're going to try to use that to build a model to predict height in centimeters for Kalama children. Kalama is a village in Africa somewhere, and this is data collected from those children. All right, so I've got Staplet going on in a different window. You're going to go to quantitative variables, and this is where your data goes, okay? So I'm going to skip to this one where I've already put the data in. You're going to type in your variables with their units of measure and all your data and hit begin analysis. All right, once you hit begin analysis, you're going to get a scatter plot. You're might as well go ahead and hit calculate correlation. That's going to give you R. Go ahead and hit calculate least squares regression line. That's going to give you a bunch of information. So what you're going to notice is that this has added the regression line to your points. So this line right here models these points the best. This line right here is the closest estimate of where these points fall. This is your residual plot. What this essentially is if I took this and flattened this line, these are those points around that regression line. I want to see a random scatter here, no curve pattern. You're also going to not only get the correlation R, you're going to get your regression equation here. You're going to get N, how many items you had, S, and R squared. All right, so those are all the things that you're going to get and you're going to use. Now remember that you can use a snipping tool, a cutting tool to take and cut these out of Staplet and paste them into your examples. All right, so as I'm looking at example 1, okay, that's exactly what I did. I took this scatter plot and I pasted it in from Staplet. When I interpret R, this is very strongly positive, right? I've got a value really close to +1. A very strong positive linear relationship between the age and height of Kalama children, okay? Coefficient of determination was R squared. I turned that into a percentage. I use the phrase that's in my notes, okay? Use those phrases to help you. 97.4% of the variability in height can be explained by the relationship. Whatever's left over for 100% are things that affect height besides age. I've got my regression equation. I got this out of Staplet, but notice that instead of y hat, I wrote in predicted height. Instead of X, I wrote in age. I want you to make sure that you do that. My slope. I predict an increase of about 6.62 centimeters, round it off if you want to, in height for each additional month of age. So I expect every kid to grow about 0.62 centimeters every additional month. My y-intercept, this would be the height that I predict at birth when X is 0. When you want to make a prediction, you have to take this 32 age and put it in the regression equation, and you've got to run this right here through the calculator to get a prediction, okay? So at 32 months old, our model predicts a height of about 85 centimeters. Okay, on the residuals, you can hover over the residual plot when you are in Staplet at 22, so find an X at 22, hover over the points till you find it, and then it's going to tell you what the residual is at that point. That essentially means, since this is below my regression line, okay, that our actual value is this far below what our model would predict, okay? The last thing it asks for the entire residual plot. So again, I copied and pasted this from Staplet. Remember, what I want to see here is a nice random scatter. I don't want to see a curved pattern. Thanks for watching example 1.